The Primordial Era. The Primordial Era spans from the exact moment of the Big Bang, 13.8 billion years ago, to roughly 370,000 years after the universe's creation. At the instant of the Big Bang, the universe does not expand into pre-existing space. Rather, space itself violently expands outward. During the first fraction of a second, an event known as cosmic inflation occurs, stretching the fabric of reality faster than the speed of light. At this point, the universe is a hyperdense, superheated soup of energy. It is so blisteringly hot that the four fundamental forces of nature, gravity, electromagnetism, the strong nuclear force, and the weak nuclear force, are unified into a single, indistinguishable force. As the universe expands, it begins to cool. Within the first microsecond, the universe enters the quark epoch. The temperature drops just enough for the strong nuclear force to separate, allowing quarks and gluons to bind together to form the very first protons and neutrons. However, the universe is still a rapidly expanding plasma, so dense and energetic that electrons cannot bind to these new atomic nuclei. Because free electrons are continuously scattering photons, light cannot travel. If you were present during the Primordial Era, you would not see the black vacuum of space. You would be surrounded by an opaque, glowing, superheated fog. The universe is entirely blind. Around the 370,000-year mark, a massive shift occurs. The temperature drops to about 3,000 Kelvin, crossing a critical threshold. This allows the free-floating electrons to finally slow down and latch on to protons, creating the first stable atoms of hydrogen and helium. This event is called recombination. Because the electrons are now locked into atomic orbits, they stop scattering light. For the exact first time in the history of the cosmos, photons are able to travel in a straight line. The glowing fog clears, and the universe becomes transparent. The brilliant flash of light from this exact moment of clearing has been traveling through space ever since, stretched by the expansion of the universe into the microwave spectrum. We observe this today as the cosmic microwave background, the oldest fossilized light in existence, and the definitive end of the Primordial Era. The Stelliferous Era. The Stelliferous Era translates to the era of stars. This is the epoch we live in right now, lasting until the universe is 100 trillion years old. Gravity pulls primordial gas into massive clouds called nebulae. The intense pressure at their cores ignites nuclear fusion, and the first stars are born. Inside these stars, fusion crushes hydrogen into heavier elements. Massive blue giants burn through their fuel in a few million years and explode in supernovas, scattering elements to build rocky planets and biological life. But the undisputed kings of this era are red dwarfs. These small stars burn fuel so efficiently they live for trillions of years. However, the universe has a finite supply of gas. As space expands, star formation will eventually stop. When the final red dwarf exhausts its fuel and flickers out, the lights of the universe will be turned off. The Degenerate Era. Spanning from 100 trillion to 10 undecillion years in the future, the Degenerate Era is defined by a dead universe. There are no living stars. The cosmos is populated entirely by stellar corpses, white dwarfs, neutron stars, and black holes. The universe is pitch black and freezing cold, with faint illumination coming only from white dwarfs slowly cooling into frozen black dwarfs. Galaxies dissolve as dead stars are ejected into the intergalactic void or consumed by supermassive black holes. As this era drags on, a mechanism called proton decay threatens reality itself. Over roughly 10 to the 34th power years, protons will spontaneously break apart and annihilate into pure radiation. Every frozen planet, dead moon, and black dwarf will literally dissolve. By the end of this era, matter as we know it ceases to exist. The Black Hole Era. The year is 10 to the 40th power. All ordinary matter has decayed. The only macroscopic objects left in the entire expanding universe are black holes, which spent the previous eras swallowing stars and galactic cores. But even black holes are not immortal. Their fate is governed by Hawking radiation. At the edge of a black hole's event horizon, pairs of virtual particles constantly pop into existence. Occasionally, one particle falls in while the other escapes, causing the black hole to emit a tiny stream of thermal radiation. The black hole is slowly evaporating. This process is incomprehensibly slow. A supermassive black hole will take a googol of years, a 1 followed by 100 zeros, to vanish. As it shrinks, it gets hotter, eventually detonating in a blinding explosion of high-energy gamma rays. When the final black hole pops, the macroscopic universe is completely erased. The Dark Era. Beginning at 10 to the 101st power years and lasting for all eternity, the Dark Era is the final, permanent state of the cosmos. There are no stars, planets, atoms, or black holes. The universe consists entirely of an impossibly dilute, freezing fog of elementary particles: photons, neutrinos, electrons, and positrons. These particles are separated by unimaginable distances, ensuring they will likely never interact again. The temperature drops to a fraction of a degree above absolute zero. The universe has achieved heat death. Thermodynamic entropy reaches its maximum, meaning energy is perfectly, evenly distributed. Without gradients, no heat flows and no work can be done. The cosmos is frozen in ultimate equilibrium, and the very concept of time loses its meaning forever.